Hi, welcome back to LeetCode. So in this video, discuss LeetCode problem 3638, maximum balanced shipments. You are given an integer array weight of length n representing the weights of n parcels arranged in a straight line. A shipment is defined as a contiguous survey of parcels. A shipment is considered balanced. When it will call it balanced if the weight of the last parcel is strictly less than the maximum weight among all parcels in that shipment. So select a set of non-overlapping contiguous balanced shipments such that each parcel appears in at most one shipment. So parcels may be remain unshipped. Return the maximum possible number of balanced shipments that can be formed. So that means I have to maximize the number of shipments now, and each shipment, like one parcel can be shipped only once, right? So it can be part of only one shipment, and when it will called as a balanced shipment, so it will be balanced if the last parcel weight is less than the maximum weight in this shipment. The weight of last parcel is less than the maximum weight of this shipment. Suppose I measure this to I have to the last element, the last parcel of the current shipment. So is it possible? No, because there is no previous parcels, right? So this is not possible. So let's see, I measure 2 and 5. Is this a balanced shipment? No, because the last element it is still 5 and 5 is less than the maximum element is 5, so not possible. Okay, so this is not a valid shipment. Next is, suppose I measure this 1 is the last parcel of the shipment. So 5, can I take 5? Let's see, 5 and 1. So what is the minimum? What is last parcel weight? 1. Is this the maximum weight of all of these parcels? 5. What is the maximum weight? 5. So 1 is less than 5? Yes. So this is one valid shipment. Next is 2, 5, 1. So 1 is the last element, maximum weight is 5. So this is also a valid shipment. Next is, suppose 4 is the last parcel. So with 1 and 4, is it possible? The last parcel weight is 4 and the maximum weight it is also 4. So this is not a valid parcel. Next is 5, 1, 4. Last parcel weight is 4 and the maximum weight is 5. So 4 is less than 5. Yes. So this is a valid parcel. Okay. Next 2, 5, 1, 4. So last parcel weight is 4 and the maximum weight is 5. This is also valid. This is also valid. Next is 3. So suppose 4 and 3. This is the shipment I am trying to actually create. So last parcel weight is 3. Maximum weight is 4. So this is also valid. Okay. Next is 1, 4, 3. So last parcel weight is 3 and the maximum weight is also 4. So this is also valid. Next is 5, 1, 4, 3. So last parcel weight is 3, maximum weight is 5. This is also valid. Next is 2, 5, 1, 4, 3. So the last parcel weight is 3 and the maximum weight is 5. So this is also valid. 3 less than 5. So this is also valid. So which actually shipment actually I can create? One shipment actually I can create with this 2, 5 and 1. 2, 5 and 1. This 5 and 1. So 5 and 1. So that means if I actually assign some index here 0, 1, 2, 3, 4. So first shipment actually I can actually generate. That's actually 5 and 1. That means 1 and 2. This is one shipment actually I can generate, index 1 and 2. Next is this 2 to 1. That means 0 to 2. This is one shipment actually I can generate. Next is 1 to 4. This is not a valid. 5 to 4. So that means 1 to 3. Next is 1 to 3. Next is 2 to 4. 2 to 4 index is 0 to 3. Next, I can generate 4 and 3. 4 and 3, that means 3 to 4. 3 to 4, then 2 to 4. Yes, all actually valid. So that means 2 to 4, 1 to 4, and 0 to 4. These actually the valid shipments actually I can generate. I can actually do. But what is your target? Target is to maximize the number of shipment, right? So maximize the number of shipments. So suppose I have, this is one shipment 1 and 2. So which next shipment actually I can take actually? Can I actually take 0 to 2? No, because this is already part of this shipment. So 1 and 3, no, because this is overlapping, because 1 and 2 already actually shipped here, first shipment. Next is 0 to 3, not possible. 3 to 4, yes, this actually I can take. Next 2 to 4, 2 to 4 not possible because 3 to 4 I have already taken. 1 to 4 not possible, this is overlapping. 0 to 4 not possible. So only in this actually way actually I can actually take only 2 shipment actually I can do. But our target is to maximize the number of shipment. Next is this is one shipment. So for this the answer is 2. Suppose I have taken only 0 to 2. 0 to 2, then actually can I take 1 and 3? Not possible because 1 and 2 it will be overlap. Then can I actually take 0 to 3? Not possible, it will overlap with 0 and 2. 3 to 4, yes, I can actually take 3 to 4. Can I actually take 2 to 4? Not possible, it will overlap. Next 1 to 4, no, it will overlap. 0 to 4, it will overlap. So in this also I can actually take only 2 shipment. So in this actually I have to check all the combination. Like suppose actually I actually assume this actually one bit. Suppose this is actually first bit or 0th bit, first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, and seventh bit. So suppose there are actually n different shipment actually I can do, paid shipment. But using that shipment I actually try to combine like how many actually different combinations are possible. 2 to the power n minus 1, right? 2 to the power n minus 1. So suppose I will check that using the value 1, what shipment actually I can take. Then using that shipment actually I can check that this actually the valid, there is any overlapping or not. If there is no overlap, then I will check the how many shipment actually I can do. So what will be time history for this? So if there is n actually the total number of actually valid shipments I can do, then time history will be 2 to the power n, roughly 2 to the power n. So it actually gives us clearly, because here actually you can see the n value is 10 to the power 5. Got it? So it will clearly. So how to optimize this? So let's try to optimize this. How can I optimize? So actually you can think the meeting scheduling, maximum number of meetings scheduling, that problem. That suppose we know the interval 0 to 2, this is one valid shipment actually I can do. Suppose 1 and 3, suppose 4 and 5, in this way. So first of all actually I will actually sort with according to the finish time. Suppose this will actually finish first. 1 finish 1, this is finish 2, finish 3, finish 4. So I will actually try to take this shipment because it will actually finish first. That means the range is small. Here actually the with respect to the meeting, actually the what will finish is the range of the last parcel index. So if actually ending fast, so that means I can actually in the future in the right side, so I can actually get the I can actually accommodate maximum number of actually shipment. So that's why here also the same case in the meeting scheduling problem also, that we have to, our goal is to maximize the maximum number of meeting I can actually schedule. So our target was to schedule the meeting that will actually finish fast. So then actually it will actually free the space fast, because it will actually end fast, this first event, first meeting. So I can actually the meeting room that will be empty, then actually I can actually assign new meeting that time. So that's why our target is to take the whatever actually meeting, it will finish fast. Okay, similar here also I know whatever actually interval I can actually generate. this is the meeting interval with respect to the parcel shipment. Then I just sort with respect to the last parcel index. Okay, last parcel index. For that, our target is to try to take the shipment last index is less. Try to take that shipment, right? Suppose for this example, similar way, 1, 2, so let's see. So sort with respect to the finish time. So what is the finish time? So this is already sorted with respect to finish time. Okay. So that means first try to take this. Okay. 1 and 2. Next, what actually I can take? I can take only the meeting that actually start after that. So it will finish at the time 2. So I can schedule only meeting after time 2. So can actually schedule this? No, because it start with 1. 0 can actually start this? No. 3 can actually start this? Yes. So 3 to 4. Okay, so now our ending time is 4. So is there anything actually I can accommodate? No. So that's why for this example the output is 2. Clear? What the output is 2. Similar way, suppose 4 comma 4. 4 comma 4. What is the valid shipment actually I can generate? So if this is, I assume that this is the last element of last parcel of the shipment. So is there any previous element? Maximum element also 4, and 4 less than 4? No. So this is not a valid shipment. Similarly, if I try to take this as a shipment 4 comma 4, so what is the last parcel weight? Last parcel weight is 4. Also the maximum weight parcel is also 4. So this is not possible. So there is no valid shipment I can generate. So that's why our answer will be 0. Clear? So let's see another example. 4 to 1. Suppose 3, 5. So this is not possible. 4 2, yes, 4 2 is possible. Then 4 1, yes, 4 1 is also possible. 4 2 1 is also possible. Sorry, this actually it should be with respect to the index, right? 0 1 2 3 4. So yes, 0 1 is possible. 0 2 is also possible. Then 0 3 is possible. Last word is actually 3 and the maximum word is 4. Yes, 0 3 is also possible. Then 1 2 possible. Yes, 1 2 is also possible. Then anything else? 0 1 0 2 0 3 0 4, yes, possible? No, because the last word is actually 5 and the maximum word is also 5. So 0 5 is not possible. Sorry, 0 4 is not possible. Then 1 2, this is possible. 1 3, 1 3, last word is 3. No, this is not possible. So remove this. Next, 1 4, no, not possible. The maximum word is 5 and the last word parcel is also 5. So this is not possible. 2 comma 3, this is possible? No, this is also not possible. Then 2 comma 4, no, last word is parcel is 5. Also the maximum word is also 5. Similar 3 comma 4, 3 comma 4, no, not possible, because here actually the last word parcel is actually is 5 and the maximum word is also 5. 3 comma 4 also not possible. So these 4 valid actually shipment actually I can do. So now sort this with respect to the finish time. So this will be sorted with respect to 0 comma 1, then 0 comma 2, 1 comma 2, 0 comma 3. Clear? I have sorted these intervals. Now try to take the first event that actually finish first, right? So I will take 0 comma 1. Next actually what actually even if I can get, I can actually take 1, can actually take 1 comma 2? Not possible, because 1 is already part of the previous shipment. Can actually take 0 comma 3? Not possible. So only 1 is the answer. So 1 is the answer. I can actually take maximum number of shipment I can do, that actually one shipment. Clear? That is something I can do. this 4 to 3 is also possible, 4 to 2 is also possible, then 2 to 1 is also possible, right? 4 to 1 is also possible. Clear? So I can do only one shipment. Clear? Now go to the code. So first of all, find out all the valid intervals, right? So that will be the meeting intervals here. So first of all, for that I have to know that what is actually the previous maximum element actually I have, right? So that's why I'll take one stack that will store the index, and the previous greater that actually in the vector actually I will take the, what it indicates the current index I. For the index I, what is the previous maximum element I have seen. So why actually I am using the monotonic stack here. This is the using concept of monotonic stack, because here actually you can see that these strings will be overlapping 0 to 1, 0 to 2, 1 to 2. Just see these two, 0 to 2 and 1 comma 2. I should take only the nearest leftmost nearest maximum element 1 comma 2, because these may actually increase the increase the number of shipments. So if I actually take 0 comma 2, that actually anyways actually overlap, it will actually increase the chances to overlap, right? So that's why take only the nearest leftmost maximum element. Got it? Clear? Why should I use the monotonic stack here? Because it actually increases the, if I actually take these intervals, so it actually increases the chances of overlapping. So that's why try to discard this and only take whatever leftmost actually nearest actually I have maximum element. So that's why I'm using the stack here, monotonic stack, that actually store the leftmost actually maximum element index. So initially all actually index is -1, that indicates there is no previous element, -1 previous maximum element, so that indicates by -1. Now iterate with all index from 0 to n-1. I will actually pop element from the stack that actually I have. I will check that when actually I will pop that if only the weight actually I have that actually less than the current weight. Means what you're trying to reach. I am assuming the last current index R is the last parcel. So with respect to that, I have to find out what is the nearest leftmost actually index actually I have, that actually weight is greater than the last current weight or the last parcel, because the current last parcel is the current index. The current index is the last parcel. So weight of R. So I'll check. I'll pop till I'll check that whatever the index actually I have in the stack, that weight is still less than equal to the current in weight, so that I will pop. So I'll check after that pop. It is possible that our stack is now empty. So if the stack is not empty, so then actually I will modify that whatever the nearest last index I actually have, that actually get from the stack top. So top index will be stored assigned to this current index R. Clear? And also the current index, insert the current index to the stack, because it is possible that this is actually the maximum element for the next element. So that's why I store this into the stack. So after this for loop, in the previous greater vector, actually I can easily say that for any index I, what is the nearest leftmost index actually I have that actually greater than the weight is greater than the current weight. I actually have current weight of the R, I. Okay. Now what actually I have to do? I have to generate the intervals. Interval means the maximum parcel weight to the current index I. So how to check that? So I actually generate vector of pairs. So that actually intervals this is actually the starting index, that is the maximum element index, and this is the current index I. So I'll iterate from 0 to n-1. I'll check that if previous greater element is not equal to -1, that means we actually have found some maximum element in the left side. So if it is -1, that means there is no maximum element in the left side. So that's why if it is not equal to -1, then actually I will store what is the leftmost maximum element index, previous greater of the I, and the current index I, and store this into the intervals. Got it? Now after that, actually I have this. So just see here. So I know this 0 to 1, yes, 0 to 1, 0 to 1 is one interval, and 1 to 2, yes, any other intervals 1 to 3, No, not possible. 3 to 5, not possible. Yes, this is one interval 4 to 3, 0 to 3. Clear? 0 to 3. So these three intervals are still possible. Now I have to sort this. So I sort this with according to the finish time or the last parcel index here actually. So this is already sorted with respect to this. This is actually the last parcel index. So now what I will do, I have to know that what is the last time. This is initially with -1. So first of all, try to take this. Honestly, I can take if the start time is greater than the last time, then actually I can actually assign this. I can start this current meeting. So that's why our answer is initially 0. This actually return the number of shipments I can do, and last ending time is -1 initially. Now actually I will iterate all the intervals. Before iterating that, just see what is I have sorted. So I have sorted according to the finish time, a dot second. That means the last parcel index. Got it? So I will check that whatever the last time actually I have, last end time. If it is the start time of the current meeting or the current interval, if it is greater than that, then actually I can actually start this meeting. If actually assume this actually meeting, so I know what is the finish time of the previous meeting. Okay, if the finish time of the previous event is less than the current start time of the current meeting, then actually I can start the current meeting. So that's why I will actually increase the answer, because this is actually new meeting, so I can actually schedule answer plus, and the next finish time will be whatever the actually finish time actually I have for the current meeting, that will be I dot second. Actually the next index, last parcel index. Again go to the next intervals. Got it? So in this actually, in the right answer actually I have the maximum number of actually shipment actually I can do. So how actually ensuring that this actually give us the maximum number of shipment, because I have already sorted according to the finish time or the last parcel index. So it may possible that this is actually the our graph actually look like this. So this is one shipment 1, shipment 2, shipment 3, shipment 4. So first of all, this actually finish first. So I will actually start this. I will do that finish shipment. Next, can I actually take this shipment? No, because some parcel already actually shipped in the previous shipment. Next, can I actually start this shipment S3? Yes, because the last parcel I have shipped, that actually the index suppose 1 and it is starting with 4. So I can actually do that. Okay. So can actually okay. So this is one shipment. This is second shipment. This is, can actually do this shipment 4? No, because some parcel already actually shipped in the previous shipment. So that's why we can't take this. So there is no more intervals or no more shipments. So our maximum I can actually do 2 shipments, because I have already finished sorted all according to the finish time. So it actually in the future actually it actually try to actually accommodate more number of shipments. Got it? So I hope this is clear. And if you found this video useful, please like the video, and if you not yet subscribed, please subscribe channel. Thank you. Bye bye.